Do you know the efforts engineers made to straighten the Leaning Tower of Pisa? First, let's talk about why it leans. Around 1 to 2 million years ago, a river formed in central Italy. Due to the tides, the sea and the river deposited more sand to the north and more clay to the south. In 1173, construction of the bell tower began. 5 years later, when 1/3 of the total height was built, construction was interrupted due to war with the neighboring country. This pause lasted almost a century. When construction resumed, the tower had already started leaning, but the masons didn't dismantle and rebuild it. Instead, they tried to compensate by building one side higher to restore vertical alignment. By 1278, they had reached the 7th floor. Due to another war, construction stopped again, lasting another century. Finally, in 1372, the Leaning Tower of Pisa was completed. To maintain stability, the southern side of the top has 6 steps, while the northern side has only 4. After the completion of this crooked tower, no one cared how much it leaned or if it would collapse. It wasn't until 1817 that the first recorded measurement showed the tilt at about 4.9 degrees, and it continued to worsen. By 1990, the Leaning Tower's tilt had increased to an average of 5.5 degrees. Engineers realized they could no longer ignore the issue and began searching for solutions. First, they installed modern monitoring equipment to better track the tower's movements over time. They built a concrete ring around the base and placed about 600 tons of counterweights on the north side as a balancing structure. Each time they added a layer of counterweight, they monitored the tower's tilt through the equipment. After several months, the tilt was reduced by 48 arcseconds, a small improvement of about 1%, but progress nonetheless. Later, for aesthetic reasons, the engineers planned to replace the visible counterweights with deep anchors buried underground to pull the north side of the tower toward the ground. However, this operation proved difficult. They hypothesized that the base's right-angled structure was separate from the tower itself, with part of the support resting on that angle. This project required dismantling part of the right angle to make room for the concrete blocks. But if they did this, the tower would lose support, causing it to tilt again at a rate of 4 arcseconds per day, accelerating its collapse. So this plan was abandoned, and they continued using the 350 tons of counterweights to temporarily prevent further tilting. Soon, a third idea emerged, extracting groundwater from the sand beneath the north side of the Leaning Tower. The engineers inserted electrodes into the soil and passed an electric current through the clay particles, which carry a negative charge. Since most of the ions in the water between the particles are positively charged, the clay would solidify. They applied a voltage to the soil to cause the water to migrate toward the cathode and then pumped it to the surface. Although the idea seemed reasonable, it didn't work because the soil's conductivity was too high. The engineers then proposed one final idea. If they couldn't solidify the soil beneath the tower, they would remove some of it for testing. In 1995, they built a large concrete structure in a nearby square, drilled slanted holes beneath the foundation, and removed some foundation. As the concrete structure began to lean, they dug out the excess soil, and it successfully returned to its normal state. Once the idea was confirmed, they began implementing the process. The engineers designed a protective system for the Leaning Tower to prevent any unexpected events during the operation. Then, the project officially began. Over the course of 5 months, the tilt of the tower was reduced by 90 milliseconds. After drilling 41 holes, the tower gradually began to straighten, with a total of 38 cubic meters of soil being removed. The counterweights were dismantled, and a drainage system was installed nearby to control fluctuations in the groundwater level. Ultimately, this project restored the tower's position by half a degree, significantly reducing the risk of collapse in the short term.